What if I could give you some steps that would work for just about every word problem? I know how you like them. Well, we're going to do that. But before we do that, let's look at the phrases that we use within word problems before we get to them. The words that suggest addition, the word sum, of course the sum of A and B, means A plus B. More than, that phrase is interpreted as addition. 8 more than x means I started with x, that's why I put that first, and I have 8 more than that, so x plus 8. The word total, usually for more than 2, the word total infers addition as well. So that's going to be A plus B plus C. And increased by is another one that infers addition. Now it starts getting a little trickier when we talk about subtraction, especially with the word from. A subtracted from B meant that I start, even though A is listed first, I started with B and subtracted A from it. That's kind of backwards, isn't it? But that's the way it is. A subtracted from B is B minus A. 8 less than x means I started with x and I have 8 less than that. So don't always go by the number or letter that they list first. You have to read the English and interpret it. The word difference infers subtraction, and we keep the same order. The difference of y and c is y minus c. And decreased by is also going to lead to subtraction. Z decreased by 3 would be z minus 3. Okay, that's probably the trickiest of the 4. Let's look at multiplication. The word product is the answer by definition to a multiplication problem. So the product of A and B is A times B. The word of smells like multiplication all the time. 8 of x means 8x. If you see of, I always think of those things that they sell eggs, those cartons. If you have 2 of those cartons, how many eggs do you have? Well, you know you have 24, and you know you multiplied to find that. So of always means times. Twice is another one. It infers a special type of multiplication, of course. Multiplication by 2. And the word times infers multiplication, but get used to, when they say y times 3, we're always going to write the number or coefficient on the left side. So let's write y times 3 as 3y, so we're all doing it the same way. The words that suggest division, well, the word quotient is the answer to a division problem. So the quotient of A and B is A divided by B. And 8 into x, now this is like from. 8 into x, I started with x and I divided it by 8. So you might have to flip that one, or you will have to flip that one. This is an easy one. Y divided by 3 is just what it says. Just note that you can represent that as a fraction, however, y over 3. Okay. Now here are the steps that I will ask you to always use in this class to solve a word problem, and I'll ask you to memorize them. The first step is to name what they want to know. Name what your variable is. It can only be one thing, so if they ask for Susie and James' age or something like that, I'm going to tell you to let it equal the smaller one, in general anyway. Let it equal the smaller one. Not always, but usually it's easier to let x be the smaller one. We'll show you in a second why. Once you've done step 2, and that is naming what x is, we're going to define any other object in the problem in x language, in terms of x. That's why we had to name x first. We had to know what it was. Okay, and I'm going to tell you, I want you to start with what you know. Start with your concepts in English and work using the things that the phrases we just covered, phrases for addition, subtraction, multiplication, and division, to put them into math language. And we're going to have you write down the problem so that you can cross out what you've assimilated as you go. So don't be too lazy. I expect you to write out the problem in your notebook. These two steps I'm going to call the Math to English Dictionary, and we're going to interpret using the Math to English Dictionary. Another reason why we're going to cross things out from what we've written down is once we've crossed everything we've assimilated out, what is left almost 100% of the time is the equation itself, which you will use your dictionary to interpret. We'll get practice with that. Once we've written the equation, we will solve the equation, because we've already covered how to solve an equation. Now note, sometimes the question asks for two things, or three things even. So just because you've solved the equation, you're not done yet. Once you've solved that equation, step 5, very important, is to answer the question. Okay? Well, we're going to use the dictionary to do that. Let's take a look at an example.
Excuse me, Professor Brain.
Oh, I forgot. There's one last step.
I haven't got a brain.
You've always got to check your answer and see if it's reasonable. Okay, so sissy on you if you don't check your answer.
I can do that, but I don't want to.
You're going to wish you did it and make sure that it's reasonable. Check your answer.
Allow me to demonstrate.
Okay, let's try one. We'll pretend you've already written this down on your paper. Kevin's age is 3 more than twice Jane's age. The sum of their ages is 39. How old are Kevin and Jane? Let's begin by naming what X is. What do they want to know? Well, they want to know two things, Kevin and Jane's age. I can't let it equal both, so what I'm going to do is let it equal Jane's age, because Kevin's is larger. Okay, I'm done step 1. And I cross that out. Step 2 is to name the other objects in the problem. Now we've done Jane. We're going to start with English and work our way from English to math, defining Kevin's age in terms of our X. Well, X is Jane's age, so Kevin's age, and it says right there, is 3 more than twice Jane's. That would be 3 more than twice Jane's, and I'll cross that out. Now, there's only 2 people in this problem, Kevin and Jane, so I guess I'm done with steps 1 and 2. If there was a Tom, I'd have another person to put in step 2, but I don't. So I'm ready to write the equation from what is not crossed out. I'm going to interpret word for word from steps 1 and 2. The sum of their ages, Jane's age plus Kevin's age, is 39. That's why I crossed out, to write the equation from what's left. Okay, I have an equation. Now let's solve it. Well, I have 2 x's on the same side, so I'll combine them. And then I'll get the x alone by, in this case, subtracting a 3 from both sides and then dividing by 3. Both sides, and I get x is 12. Now I'm still not done yet. I've got to answer the question. Now what is 12? Whose age is 12? Good thing I wrote out steps 1 and 2. I know that X is Jane's age, but they still want to know Kevin's age.
Wait a minute.
Good thing I wrote that out. I can plug that 12 in and have 3 plus 2 times 12, and I can tell you Kevin's age. Kevin's age is 27. And I'm done.
Excuse me, Professor Brainiac.
Go!
I haven't got a brain.
I forgot. Always check your answer. In this case, our answers.
I can do that, but I don't want to.
You're going to wish you did on the test. Let's check the answer now. It said that the sum of their ages should be 39. So let's add their ages up. And son of a gun, it is 39. So at least check to see if it's reasonable.
Brilliance. That's all I can say. Sheer, unadulterated brilliance.
Those steps will work for you just about every time.
Thank you, sir. May I have another?
Once again, let's assume you've written it down. I expect you to write it down. And here it is. The difference between two numbers is 7. We need you to find the two numbers, both of them, if the larger number is 3 times the smaller. And we always begin by naming what we want to know. Now in this case we want to know two things, a larger number and a smaller number. What did I tell you in that case to do? Let's let x be the smaller number. And we're done step 1. Probably the most commonly skipped step. Now step 2 is to name everything else in the problem in terms of x. Now we start with English. We have the smaller number, so in English, what is the other thing? Quite easily, the larger number. And it tells us the larger number is 3 times the smaller. Good thing I named what x was. So in this case, I represent the larger number as 3 times x, or 3 times the smaller. Now what have I forgotten to do up to this point? Cross out. Let's cross out. Find the two numbers, and I've assimilated the larger number as 3 times the smaller. There isn't any other number in this problem, so I'm done steps 1 and 2, and I'm done crossing out, and it's time to do the equation. The difference between the two numbers, difference infers subtraction. The larger number minus the smaller number is 7. Good thing I wrote out steps 1 and 2, and good thing I crossed out. Okay, well I have an equation.
I'll make this look good.
Let's solve it. 3x minus 1x is actually 2x, and I have here a 2 that I have to get rid of. He's multiplying, so I'll divide both sides, and I get, in this case, x is 7 divided by 2, or 3.5. Got to answer the question, what is the smaller number and what is the larger number? Well, x in this case is the smaller number. So the smaller number is 3.5, or 3.5. The larger number, good thing I wrote out step 2, is 3 times that. 3 times 3.5 is 10.5. So there's your answers.
Is that your final answer?
No, because you better know that you have to check your answer. Let's see if it's reasonable. The difference between these two numbers is supposed to be 7. Difference infers subtraction. 10.5 minus 3.5. I'm feeling real good about this because their difference is 7. You'll need to know those steps. They'll work every time. Now let me do one more. We'll write it down, and we have Mary and Jim collecting baseball cards. Mary has 5 more than 3 times as many cards as Jim. The total number of cards they both have is 253, and they want to know only how many cards does Mary have. This is an especially tough one. I'm going to let initially x be number of cards Mary has, because that's what they want to know. Seems reasonable. But when I jump to step 2, the other thing I'll have to define is Jim's number of cards. And if you look, Jim's number of cards is not based on Mary's. Mary's is based on Jim's. So it looks like, and this happens sometimes, I'm going to have to back up and let x be Jim's cards and define x in terms of Jim's cards, in step 2, I'll define Mary's card. So sometimes, if you get confused, back up and let X be the other person or the other thing. Now, Mary's number of cards is 5 more than 3 times Jim's number. So I could let Mary's cards be 5 more than 3 times Jim's. Now, I've got both defined. I should cross out and move on to step 3. Let's write the equation. The total number of cards they both have, Jim's cards plus Mary's cards, is 253. Please note from this example, if you have trouble in step 2, move back to step 1 and redefine X. Okay? Now, let's solve this bad boy. I'm going to combine the 1x and the 3x and get 4x. And then we'll get that x alone by first subtracting 5 from both sides and then dividing by 4 to both sides. Note here that we're lining up the equal signs very nicely. And x is 62. Now here's where it's very important to answer what they asked, because 62 is not the correct answer. 62, don't get all happy, 62 is Jim's cards. They didn't want to know that. They want to know Mary's cards. So we're going to have to use what we wrote down in step 2 and say 5 plus 3 times x, or 5 plus 3 times 62, and get the answer. Now you've got the answer to the question, how many cards does Mary have? 191. And, oh, never forget to check. It's simple to check, too. Please check your answers. Well, let's see. Does the sum of these two numbers add up to what it's supposed to? I'll carry the 1. I'm feeling very good about this. That's the way to do a word problem. You're going to have to try it. So go do your homework, but remember, I expect you to write the problem, and I expect you to write out steps 1 to 5. That's the reason we're doing this, not just to get it done, but to learn the steps. Dig in.